With this example, we have the function y equals x squared, the x-axis, and x equals 2 serving as the bounds of our region. So you can see it here in green. You can also pull it up on your graphing calculator. X squared is, in essence, our upper bound, if you will. The vertical line is our right bound. The x-axis is our lower bound of our region. And we're interested in when this region is revolved around the x-axis. All right, so when we revolve this, and I'll see if I can get some animation into the video as well, we're looking at a situation where it's almost like a tornado that's on its side, if you will. All right, it's very skinny down here and quite wide. We have a large radius when this is revolved around the x-axis in that spot. We want to find the volume of this solid, all right, and we're going to use that disk method. So just putting that in, we know the volume is equal to pi times the integral from a to b of our function squared dx. Our function is x squared, so we're going to have x squared being squared as far as the integrand is concerned. In our bounds, well, the leftmost point is at x equals 0, and the rightmost point is when x equals 2, so they serve as our bounds. We have to solve this definite integral in order to find the volume of the solid that would be generated when that green region is rotated around or revolved around the x-axis. So as we do that, we want to solve this definite integral. We want to use the fundamental theorem of calculus. We need to kind of simplify this real quick in order to find our antiderivative. We have x squared being squared, which would be equal to x to the 4th. Yes, all right, so we have pi times the integral from 0 to 2 of x to the 4th dx. Now we can antiderive using our rules for antidifferentiation. So the pi is hanging out front, x to the 4th. Yep, that will become x to the 5th over 5, and it's being evaluated from 0 to 2. So again, the pi is just chilling out front. We plug in 2 to the 5th minus 0 to the 5th. Both of those are over 5. 0 is our great friend when we're finding our definite integrals. Quite often it produces a 0, as it does here. So we have, that's a little misleading. We have 2 to the 5th, or 32 over 5, and then we also have pi. So we're looking at a final answer of 32 pi over 5 as the volume of that solid which is formed when that region is revolved around the x-axis.